Namaste everyone. Welcome back to our channel. Today, we are diving into a truly fascinating and advanced topic, Decentralized Applications or dApps, and how we, as Java developers, can understand and even interact with them. This is a game changer for the internet, and understanding it is crucial for every modern developer. In this 5-minute tutorial, we will explore the core concepts, look at how Java fits into this ecosystem, and even touch upon some practical interactions. So, grab your chai, and let us begin this exciting journey. Alright, let us start with the very foundation of dApps, the blockchain. Imagine a digital ledger, but instead of being controlled by one central authority, it is distributed across thousands of computers worldwide. Each new transaction, or block of data, is cryptographically linked to the previous one, forming an unbreakable chain. This makes the data immutable, meaning it cannot be changed once recorded, and transparent, as everyone on the network can see it. It is like a public, unchangeable record book. This distributed and secure nature is what gives dApps their power and resilience, unlike traditional applications that rely on central servers which can be single points of failure. This fundamental shift from centralized to decentralized infrastructure is the heart of the dApp revolution. Understanding this distributed ledger technology is your first step. Now, how do these dApps actually perform complex logic? That is where smart contracts come in. Think of a smart contract as a self-executing agreement or a program stored directly on the blockchain. Once deployed, its code runs exactly as programmed, without any possibility of censorship, downtime, or third-party interference. It is like a vending machine. You put in money, it dispenses a drink automatically. No human intervention needed. These smart contracts are typically written in specialized languages like Solidity for the Ethereum blockchain. And where does Java fit? Well, we use Java to interact with these smart contracts from the outside world. This interaction forms the bridge between our familiar Java applications and the decentralized Web3 world, allowing our Java code to read data from or send transactions to a smart contract on the blockchain. This is the essence of building robust dApp front ends or backend services in Java. Let us make this more concrete with a practical Java example using the Web3j library. Web3j is a lightweight, highly modular, reactive, and type-safe Java application programming interface for integrating with Ethereum clients. Here, we are connecting to a local Ethereum node to fetch the latest block number. First, we create an instance of Web3j by providing the uniform resource locator of our Ethereum node. Then, using eth_blockNumber.send, we retrieve the latest block. This small code snippet demonstrates how easily Java can establish a connection and query basic information from a blockchain network. Imagine this as the first step to checking balances, sending tokens, or calling functions on a smart contract. Remember, this is just a starting point, but it clearly shows the potential for Java in the decentralized space. This code is runnable, and you can test it with a local Ethereum client like Ganache. While dApps offer incredible opportunities, there are common pitfalls to be aware of. One major mistake is underestimating gas fees. Every operation on a blockchain costs gas, which translates to real money. Inefficient smart contract code can lead to very high transaction costs, making your dApp expensive to use. Another common error is neglecting security. Smart contracts, once deployed, are immutable, meaning bugs or vulnerabilities cannot be easily patched. Rigorous testing and auditing are absolutely essential. Furthermore, remember that the blockchain is public and transparent. Do not store sensitive, private user data directly on-chain. Always opt for off-chain storage solutions with on-chain references. Best practices include designing gas-efficient contracts, performing extensive security audits, and carefully considering data privacy by leveraging hybrid architectures that combine on-chain and off-chain components. And there you have it, my friends. In just a few minutes, we have journeyed through the exciting world of decentralized applications. We started by understanding the foundational concept of blockchain as a distributed, immutable ledger. Then, we explored smart contracts, the self-executing programs that power dApps, and how Java, through libraries like Web3.js, can interact with them. We also covered crucial best practices, like managing gas fees and prioritizing security. The decentralized web is a vast and evolving landscape, offering immense potential for innovation. Keep experimenting with Web3.js, deploy your own simple smart contracts, and explore the possibilities. Do not forget to like this video, share it with your fellow developers, and subscribe to our channel for more exciting Java tutorials. Keep coding, keep learning, and I will see you in the next video. Dhanyavad.